Welcome to Full Momentum, an HEC-RAS podcast. I'm your host, Ben Carey. Here joining me, as always, Chris Goodell for episode 34. And we also have a very special guest today, Jeanne McFall, who is president and principal engineer of RivHab Engineering Design. We're very happy to have Jeanne here today with us. Jeanne, welcome to the podcast.
Welcome,
Thank you. Thank you. I'm very honored to be here as well. I'm a big fan. And I've been reading your blogs for years, so I'm excited to be part of it.
Well, I'm a big fan of your work. I really enjoy when you're posting stuff up on LinkedIn about the various projects you're working on. It sounds like you just have a ton of fun and you're out in the wilderness all the time. And as you were telling us before we started recording, here you are at Silver Creek, out in the wilderness, but in a really nice cabin, it looks like.
Yes.
Next to a fantastic trout stream, huh?
Yes. Yeah, it is. I am very fortunate. I personally think that I have the best job because we work in such beautiful places and we work with landowners that really want to see the improvement. So they typically call us in because there's some limiting factors, whether it's temperature or sediment impaired, and they want to fix, help with the recovery of the ecosystem. So it's a lot of fun, and I work in the most beautiful places, mostly in Idaho and Oregon, although I'm licensed in 5 states and we're expanding. We're working towards the whole Pacific Northwest in Wyoming. So, but yeah, today I actually have a landowner meeting to share HEC-RAS results this afternoon. And when they called me over, I was hoping to do that virtual and be in my office, but they wanted me here in person. So I told them I have this and I have some meetings ahead of time. So they offered their cabin and their Wi-Fi. And
Wow.
I've been sipping their coffee, and I have this beautiful cabin right on Silver Creek all to myself, which is gorgeous.
Yeah. Well, I want to warn everybody out there who may be listening to this that Jeanne is an awesome person to follow on LinkedIn, but also be wary because you will be jealous of all the project sites and cool things that she's able to do. I always find myself very much being jealous of the stuff that you're out there doing. So one of the things, Jeanne, that I saw recently on LinkedIn regarding yourself and RivHab was the fact that you were awarded the Idaho Small Business Person of the Year Award in 2024, which I know was, I'm sure, a huge personal accomplishment and something that's really hard to get, I'm assuming, because I know Idaho is one of those states that it's growing really quickly. I'm sure there's a lot of new businesses that are starting. So what a cool deal. How did that all come together?
Thank you. I was quite honored and very surprised, actually. So I started my business a little over 4 years ago. It'll be 5 years in December. And once I started working with the Small Business Administration, they have been key in just helping, provide resources, provide financing, help with some certifications for my business. And so I've been working a lot with the SBA office, and they nominated me for this award, which was overwhelming. So as part of as being the Idaho recipient, I did get a fly to Washington, D.C. and go accept the award, which was exciting because I've never been to Washington, D.C. So I took my kids out of school. We went for a week. We saw all the sites and received this award, which has been great. But I do owe that to our Boise district office for the SBA. They're very supportive for entrepreneurs who are starting their own business. So I do highly recommend, if you're thinking about starting your own business, contact your local SBA. That's my plug.
Well, I was just thrilled to hear that news. I wasn't shocked at all, to be honest with you, because I know you well enough, Jeanne, and what you've built at your company. But I was thinking about the first time I met you was about 4 years ago. Well, maybe 5 years ago, but shortly before you started your company. So Jeanne had me come out and teach a HEC-RAS course. So she organized everything. And then we even did a pub and grub as part. Well, no, that was follow up, but that's where the whole thing started was at that class, right?
Mm-hmm.
But you were still working at Idaho Fish and Game at the time, I think, right?
Yes. I was working for the state, and I wanted do a HEC-RAS course and I wanted to come see your course live, but we were funding limited. So then I call you up and I say, well, okay, I can't come attend your course because I don't have, I can't travel out of the state of Idaho. So will you come to Boise? And we organized a great, very well attended HEC-RAS. I think it was one of your 3 or 4 day courses at the University of Idaho, Boise. Man, we had probably 30, 35. I think we sold out, whatever the cap was. And I was surprised because it was actually very selfish because I wanted to attend. So I brought you over. And the only way to do that was to host a course and get you out here. So thank you for doing that. That was a lot of fun.
It was a fun course. And I remember the room too. It was this giant auditorium. And even with 35 people, which is a big size class for us, it looked really small in this giant auditorium. But and I was up on a stage with a podium and everything. It was it was kind of like giving a TED talk or something. I don't know.
Well, but that's the opposite problem that Chris and I just had. We were just teaching a class in Atlanta, and we had 46 people in a very, very, very small room. It was quite cozy. So
that's true. But circling back to the point I was making is that was just a short time ago, and to go from starting your own business and now you've been given this amazing award, Small Business Owner Idaho of the Year award. That's just incredible and just great to hear. So congrats.
Thank you. Yeah, the business has been very successful. It helps to know really smart people like yourself and have the support that we need to get started. So yeah, we've grown. We now have 6 full-time engineers, mostly hydraulic engineers. We're all focused on stream restoration, riverscape, landscapes, ecological restoration, recovery goals. So it's a nice niche to be in, and we've been in pretty good demand. So it's definitely been very rewarding. Thank you.
I imagine you've grown out of the office that we saw when we saw you a couple of years ago. You've probably grown out of that one, huh?
We have gone through multiple offices. So I started in my living room, and I used to meet my intern in my living room, and we'd just meet inside my house. And then I got him a leased space when he came on full time. And then we went to another place that was as big as maybe, I don't know, a 20 by 20 office for 4 people. And we all just had our little desks. It was very intimate, very cozy. And then this last November, we moved into a much larger space that has room to grow. So we have now a big conference room, extra desk space so we can hire new employees, but we do have, we leased some office space. So that's been very nice. But yeah, it's been a fun journey. I mean, we were so small that my employees, we would all move our own desks. We had to, the desks would show up in our cardboard boxes, and I'd buy pizza and we'd spend a day assembling desks. And definitely from the roots up. They've been good to work with. They've been very loyal, and so it's a lot of the fun growing pains. One of my engineers is my IT person, and we all do a little bit of marketing. So it's a great experience of just growing a firm and hiring more people and having all the help that we're getting.
So really quick, Jeanne and Chris, just want to take a quick step back to kind of introduce what the goals of this particular episode are, because I'm sure everybody who's listening is curious. And one of the things that Chris and I really enjoy about this podcast is having very, very different conversations about HEC-RAS through different lenses. So for instance, a couple episodes ago, we were looking at RAS through the lens of automation using artificial intelligence. And that was a really cool conversation where we brought some guests on. The last episode I believe we published was all about younger college students graduating and deciding whether they want to go to grad school or not, how they've incorporated RAS into their college studies as well as their after school work. So really, really enjoy kind of the differentiating views on RAS and everything. And this episode, we're really excited to talk to you because of viewing kind of how you use HEC-RAS as a small business within the river restoration field. And so that's kind of the primary angle that I'm really curious to learn more about, Jeanne. And I know you have a lot of really cool examples and projects that we can talk about today. So Chris, do you want to add anything to that?
No, I think you nailed it. I mean, this is what Jeanne uses RAS for is probably my top two favorite things to do with HEC-RAS. The other one would be dam break modeling, just because it's such a challenge. But there's challenges with river restoration too, but it's a whole different type of modeling, because a lot of times you're looking at low flows, right, Jeanne? That's the primary interest. Whereas,
Right.
historically, HEC-RAS is a flood model. It wasn't originally built for modeling low flows, and it has evolved into having the capabilities to be a really good tool to assess what's going on in and around restoration projects. So I really love talking about this topic. I love when I get to do these types of jobs, and frankly, because a lot of times it means I get to go out to a really cool site. Not as much these days as I used to, but yeah, it's a really fun topic.
Sweet. Well, we're going to go rapid fire questions here in a second. But before we jump into that, I do want to just do a quick little sponsor read here. Chris and I are both very thankful to our sponsor for this episode, and that's the firm that we work for, Kleinschmidt Associates, who is known throughout the industry as a firm that provides practical solutions to complex problems affecting energy, water, and the environment. You can learn more if you're interested at kleinschmidtgroup.com. In addition to learning more about Kleinschmidt, you can also register for our upcoming 1D2D HEC-RAS class, which is going to be held online. So you can attend from anywhere in the US or internationally. We always have a lot of international students that attend our online classes. That's going to be getting started here in the beginning of October, going to run for 6 weeks. So we do 4-hour lecture sessions every Wednesday morning Pacific time, with workshops in between. It's a really, really popular format of our course, and it's filling up very, very fast. I was just talking to Chris this morning that we are not going to have very many spots left in the near future. So if you're interested, definitely go sign up on our website. And Chris, anything to add to the class or anything like that?
I was going to say, every one of my employees takes that class too, and I just have a new employee. So it's such a great class. I like that. I do appreciate that.
So we'll see Ella in class then sometime soon, I guess. Huh?
Yes, sir.
All right.
Very good.
Yeah, cool. Yeah. We have this online, but we also have. Did you mention the in-person class that we just finished up? Oh yeah, you did. Yeah, but we do that once a year too. So next summer, keep an eye out for that. If you do want to do something in person too, that's always, it's kind of a different way to learn, and some people prefer it that way. Some people prefer online. So we have both options for you.
Yep, absolutely. All right, I'll go ahead and kick us off with this rapid fire segment. Again, just learning more about Jeanne and kind of how she came up with the idea to start her own business. So I guess I'll start back at the beginning. Jeanne, where did your interest in river restoration, really come from? And when were you first exposed to HEC-RAS as well?
Okay, so my dad was an engineer with Environmental Protection Agency for 37 years. So I did grow up with an engineer influence, and we were very outdoors based, a lot of fishing, a lot of hunting. So actually, when I was a sophomore in high school, Dad took me to go see, it was a candlelight vigil for the last sockeye salmon that was coming back to Idaho. His name was Lonesome Larry. Now he's kind of a YouTube hit or something. There's a lot of information you can find on him. But it was in 1991, and I was about 16 years old. And I remember going to this candlelight vigil and listening to the governor speak and just, crying. It was just one of those moments that was very turnkey and influential on me. So it was, we've got this plight in Idaho of recovering salmon and steelhead. And so this was the very last sockeye salmon that returned to Redfish Lake, which was named because of the red backs of sockeye salmon. So there was only one left at the time. And so I remember telling my dad at that point, I'm going to do something to save the salmon. I want to see more fish. I want to make an impact in that regard. So then I went into environmental engineering. And through my career path, I got my graduate degree at Cal Poly San Luis Obispo, and then my undergrad there, and then a graduate degree, and then I found the job with Idaho Fish and Game, and it kind of came full circle because then I started working on salmon and steelhead recovery goals for specifically as the fish habitat engineer for the state of Idaho. And I was there for about 14 years, and it was very, very rewarding. Great opportunity. There wasn't a career ladder because they didn't have any other engineers in the Fish Bureau. So after a decade in that position as the state fish habitat engineer, then I worked with my supervisors and I let them know that I'm going to start my own thing, and left on very good terms. So now again, I'm just kind of, part of why I wanted to grow was because I also didn't want to just be fish centric and fish focused so much, because there's so much in the floodplains. It's the convergence of wildlife and fish. I used to have wildlife folks ask me how to increase the hydrology in our floodplains and the storage in our wetland meadows. And my job there was very fish centric. So I couldn't really work on those designs. And really, the floodplains is where it's at. So that was a big instigator for starting RivHab, is that I didn't want to just focus on fish. I wanted to focus on restoring the whole riverscape, restoring the groundwater hydrology, natural processes, sediment transport, and then also as part of that, recovering habitat for your deer, elk, moose, anything that really uses the floodplains, riparian, wetlands, birds. So that's how I got into starting my business. The first time I used HEC-RAS was in 2009. I was a consultant, and it was right before I started Fishing Game, actually. So I was a consultant for a short time, and I asked my boss to learn HEC-RAS. And so they sent me over to Portland, and I took a HEC-RAS class. And it was, as Chris mentioned, it was very flood dominated. It was based for FEMA models, and I was asking a lot of questions about log jams and designing, constrictions and fish habitat. So I got very interested in that. But at the time, I'm fairly certain that was only one-dimensional. Yeah, it was 1D modeling.
Yep.
And so it seemed somewhat limited. Now, as the technology has increased, I'm kind of a technology geek now. We've gotten LiDAR drones. I mean, with the capabilities of the 2D analysis and having really good surface and terrain models to adequately model this, it's the capabilities of RAS, as far as the analysis it can provide, but also as a communication tool. Like today, I'm here to share model results with landowners. They want to see how much the velocity is going to be increasing with some proposed conditions. So I guess that's a long answer, but that's kind of a little bit of my background, how I got to where I am, and I've been using RAS since 2009.
Well, yeah, 2D was really a game changer for restoration work.
Yeah,
I mean,
no doubt.
Trying to do restoration work with 1D, I mean, you can get some information out of it, but 2D just opens the door to so many more things you can do with that software and looking at restoration features. So yeah, you're going to say something.
It's amazing how much RAS has kind of changed in terms of being a very focused software for dam breach and FEMA modeling to something that can be so applicable to so many different areas now, whether it is bridge analysis now that we can do 2D bridges, or whether it's river restoration because of all the new features that we have, whether it's terrain modifications or other things like that. It's just such a broad hydraulic software now, and it definitely did not used to be that way. And we got news recently that the newest version that's going to be released either later this year or in 2025 is going to incorporate stormwater modeling capabilities, which is going to be really, really cool and exciting. So it's cool that the software, continues to evolve. HEC continues to push the envelope in terms of where you can use it. And Jeanne's a great example of somebody who maybe was one of those that were banging on the door for, hey, how am I going to be able to use this 1D software to analyze, near field flow patterns and whatnot? And at the time there wasn't an answer, but now we have a lot of really cool options. I also love, Jeanne, your description of kind of working in the floodplain and how much you enjoy that. And for me, that's the part that I love most about, working in water resources, is working in the floodplain and the challenges that come with that. It's such a good microcosm of some of the challenges that we face as a society in terms of balancing environmental needs with societal needs, risk reduction, habitat improvement. Like all these things are just kind of a counterbalance and moving things around to try to maximize all these different items, because there's so many different individuals and species that are impacted by work in the floodplain, and it's really cool to be kind of part of that.
One question I have, when is it going to also include groundwater interaction? That would be also a benefit when you start to see the hydrology in the groundwater recover, but that's probably down the road, I would imagine. But have you gentlemen thought about that, or had any encounters with
Well,
challenges on modeling groundwater with surface water interactions?
Well, first of all, HEC has been looking at that for some time now. In fact, even when I was working there way back in the early 2000s, there was some collaboration with a software called ModFlow to get that incorporated into RAS, and they had some testing or alpha beta versions that actually did that, but it never really went anywhere. If you look at some of the older versions too, you actually see ModFlow options built into the software. And so there was intention to do that. For whatever reason, that hasn't really come to be. Maybe in the future that'll be added. One of the the biggest challenges, and maybe the reasons it's not in there, is because the difference in movement of water in the ground versus surface water is so different. I mean, the velocity scales are so different that it's a challenge, but it's a good thing because it allows you to isolate those two areas, surface
Mm-hmm.
water versus groundwater in a lot of applications. Now, there's some where it is very important. Ben and I worked on a model, Ben more than me, but where we had very, very porous karstic type terrain, and the river would literally disappear. This is the Mackenzie River. I don't know if you've ever been on the Mackenzie, Jeanne, but there's a spot in the upper Mackenzie where it literally disappears into the ground, and then it comes out in a place called Blue Pool. And we had to incorporate that. So we had to get a little creative. Now, we couldn't discretely model the groundwater, but we could kind of account for that loss and then that gain back down at Blue Pool by getting a little creative
Mm.
with
Internal
internal boundaries and and some other things. But yeah, so right now, I guess you got to get a little creative, and there's certainly limitations if you want to incorporate groundwater, but there's some things that can be done if you get, a little creative with it.
Yeah, it's a
Mm-hmm.
great question, though. Great question.
Yeah. So I want to ask you, Jeanne, I know, but I'm sure a lot of people who are meeting you for the first time on this podcast are unaware that you are when you're not working and running RivHab, you're a big time outdoors enthusiast. You like to get out, fish, and hunt. How do you kind of use that or meld that with river restoration and your business as a whole?
Well, I will say that I think any fly fisherman would make a great river restoration, stream restoration engineer to a certain
Yeah.
degree. So we have hired less. I want to say, so we hired this one. He's a great civil engineer, background more civil, and he got the job because he has such a strong fly fishing background. And so I think it's that knowledge of where fish live, the fish habitat. You have to have I believe that it's good to help get out and interact in the resources that we protect. So I think it makes all of us a little bit more in tune with what kind of habitat we're building. So I think, fly fishing is right up the alley of what we do. And especially a lot of our clients, a good portion of our clients are fishermen. And
Hmm.
when you're trying to restore fish habitat and figure out where the good habitat is, if you've got that kind of mentality of a fly fisherman, you're halfway there. Well, that's an exaggeration, but it's definitely, they're definitely connected. It's the thought process. And then same, with yes, I love hunting. Archery hunting for elk is one of my favorite, and it's more of the challenge, but again, the eye for being connected with their needs, their habitat, limiting factors, and I feel like that makes us a just better team of understanding the recovery goals for ecological restoration.
I imagine it
And
makes stakeholder engagement a whole lot easier, just in terms of naturally connecting with the people that are very interested in the outcome of your projects too.
yes, yeah, that definitely, just that personal connection, having something in common helps a lot too. We just took our whole team on a fly fishing trip on the South Fork Boise River for a day
Wow.
outing, just to make sure everyone kind of understands. And we're floating the river, and I'm pointing out the boulder habitat and some side channel inundation areas, lateral habitat, depositional zones. You get on the river as a team, and you start. I think that awareness of the geomorphic processes that are happening is really valuable. And so the more you're out, the more you understand that. So yes, I'm an advocate for conservation and sportsman activities that get you outdoors for sure.
Yeah, I like what you said about fly fishing and the perspective you get and the understanding of the hydraulics that you get from literally being in the river, and having to understand the flow patterns, right? That kind of directs you on where to cast and where the fish are likely to be. And I always tell people in the class, or if I'm mentoring somebody, like, you need to get out to the river. You need to understand how flow patterns work to be a good hydraulic modeler. And whether that's fly fishing, or what I did earlier in my career is I decided I was going to learn how to whitewater kayak. So I did a lot of kayaking, and that was my way of understanding the river and flow patterns and how they interact around solid objects, rocks and trees and that sort of thing. But I always tell people, do one of those two things: get into fly fishing or getting into kayaking, and that's going to really give you a better understanding, appreciation of how water moves through a system.
Yeah, we talk about, Chris, how sometimes having calibration data for a particular site is really difficult to acquire. But I think having those experiences, whether it's whitewater rafting or fly fishing, really puts you in a position to qualitatively assess the results of your model and understand, does this make sense, right? That kind of gut check idea. And the only way you get that is if you have experience being out on the water and being able to look at results and say, this might not be 100% spot on, but it looks right. And sometimes that's very, very valuable, especially when you have a lack of calibration data. So
right. Yeah. I had a mentor in Fish and Game in my early days, and he said, put on a snorkel mask and start snorkeling the log jams you see. And just, of course you see a lot more fish activity there, but you start to notice the flow patterns and how you're going to design that and how you're going to represent that in a hydraulic model. It really helps. I think just visualizing it, seeing it, understanding it makes you a better hydraulic modeler.
Yeah, I mean, all models have uncertainty in them, right? We can't have the perfect model ever, but having that intimate knowledge of how a river works, whether you do kayaking or fly fishing or snorkeling, that narrows the uncertainty band tremendously. So, yeah.
Jeanne, you already described a little bit on, when you started your business and how you did that. I'm curious, just for somebody or for anybody who's listening, who's interested in, eventually starting their own business and utilizing HEC-RAS or whatnot. What have been the biggest challenges and maybe the biggest rewards with making that leap of faith?
Well, gosh, one of the biggest challenges is making the commitment to start hiring full-time staff and offering benefits. Just as a business owner in general, it was definitely a scary leap of faith. But I would highly encourage it for anyone listening who's considering that route. One of the things that I wish I would have known about sooner, I mentioned the SBA. They really do have some great resources, and I didn't really know about them. I started my business December 2019. 6 months later, COVID hit. So there were no in-person conferences. All the small business conferences got canceled. American Fishery Societies or other conferences that I usually attend got canceled. So it was a little independent, it felt like, for the first couple of years. And through that, it was all just based on existing relationships I had already established, which was fantastic. But then once conferences started opening and I started utilizing some of the resources for business owners, that was really helpful. So I would definitely advise. There's a lot of opportunities out there for business owners. One thing I love about RAS is that it's free. So it's right away when we get new employees in the door, they're learning it on day one. And if they don't already know it. So it's just so connected with what we do. And I mentioned we now have a fleet of drones. And so we are very in touch with the data that you put into the models. So we have a pretty good understanding of just GIS and the surface models. And then when you put the hydraulics on top of it, having that as a communication tool has been really, really valuable. Challenges for me personally is I wasn't a GIS user much before, but RAS Mapper has definitely improved. Just the familiarity with Mapper and GIS has really helped improve that process too. But to answer your questions.
Yeah, absolutely.
Yeah,
No, that's great. And I think it's a great segue too. We can actually maybe move into this next and save the project discussion here for the last portion of the podcast. You mentioned the fact that you all do some LiDAR data collection, and that's another topic I'm really interested in learning more about today. Chris and I always talk about how important terrain data is for accurate 2D hydraulic models, right? And it's often something that people don't really think about until they start building their model, and then they realize that maybe they need some additional detailed data, or they need bathymetric data that they don't have. And there are, fortunately, today, there's a lot more publicly available LiDAR data for many areas of the country than we had, 5 or 10 years ago. But there's still, I think, the need, especially when we talk about near field restoration models, to get maybe data that's better than what is publicly available. So, Jeanne, if you want to talk a little bit more about kind of how you all made the decision that you were going to start collecting that yourself, when you make the decision to actually go out and do your own LiDAR data collection, and what that looks like,
and how you actually do it. Yeah, I want to know
how you actually do
that. Yeah, no problem. And I can share a little bit here too. I started collecting LiDAR ourselves. It was a big investment because, the cost of the technology, the cost of the drones, training pilots. But what I found is that there's a lot of areas where, especially in rural countries, especially in rural counties, there's a lot of areas that don't have available LiDAR, or perhaps the LiDAR is so old that, when you're working with river systems and sediment transport, they're so dynamic, and sometimes you get a LiDAR set and it's changed significantly, and you're asked to do some design off of it. So, for example, we were working on a project on the Teton River, near the mouth of the Teton River, below where a dam failure was, and the river itself was in such a quick recovery process that the LiDAR was flown in 2018, and we went up to go verify it, and ground survey it, and the whole river has now shifted, up to 40 feet from where the LiDAR was just 5 years ago. So when you're working with these dynamic river systems, as you mentioned, every model has a certain level of error. And if you can work to reduce that error as much as possible, then it's just more advantageous for your design and your design process. So we had worked with subcontractors flying LiDAR, multiple projects, but there was such a time lapse. You become dependent on your subcontractor. You have to get on their schedule. Some of it was fixed wing. Some of it we wouldn't get back for 4 or 5 months, and we're trying to work on a shorter time scale for the design. So after getting frustrated with some subcontractors, that's when I decided that, and I had a little bit of the drone background as well, because I was flying ortho imagery already. So that's when I decided to make the leap to a LiDAR drone. So it was a big expense, big investment for us, but I tell you, it has paid off. It's a game changer really for the survey that we're collecting on the site. For the ability to run relative elevation models and start to look at the flow, the floodway, and the potential for restoration at the site on the flood plains. So this is just an example of, this is some LiDAR data that we collected. This is at the confluence. You've got the Lochsaw River here, and there's a tributary coming in central Idaho near the Montana border. And you can see very, very heavily dense vegetation, big conifer trees. And so we were asked to come in and provide fish passage at this confluence. As you can see, you can't even hardly see it. And if we had a rover, there was not the ability to pick up the satellites to our base station because it's so dense. And so essentially our LiDAR is a flying rover. It's a flying receiver. It reads to the same base station, and then you put your bird in the air, and you're collecting 600,000 points in 1 square meter. I mean, the density has just been incredible. So this is just an example. This is of the vegetation, the kind of vegetation that we collect, and then we process it, and we can come up with this bare earth model, which a ground survey crew, I mean, it would have taken weeks, and they still probably wouldn't have gotten, all these fine little details. Because of the vegetation so dense, there is some holes in the data, but even with the holes in the data, you're getting such better data from having the LiDAR. And this is an area that there was no publicly available LiDAR. So you can start to see this tributary that flows in underneath the highway here. And this is where we were doing some fish passage work. So now we could build an actual 2D model of the tributary plus the 2D model of the Locksoff or confluence model. But without I think that sort of bare earth model and the LiDAR capabilities, it would have been very limited. And then we would just introduce more error to your model. And of course, the whole goal of precise engineering is to get it as good as possible. I've got another one we've got where, go ahead.
A quick follow-up, Jeanne. So when you're collecting this information, does your drone need to have the same sort of satellite convergence as you would typically on a RTK GPS rover, or because of the fact that you're up at a higher elevation, you can sometimes get out of some of the interference areas? Because we do quite a bit of surveying, and that's always a big concern of ours, is whenever we're trying to go collect terrain data, whether it's with a GPS rover or whatnot, having those satellite connections is so key. Is that a limitation here or not?
Not with the bird in the air. Essentially, it takes, we have done a lot of survey too, where you're limited either with canyon walls, canopy cover, and when your rover is only 2 meters above ground, it can prevent you from getting survey points at all. So the rover that we have in the air with the LiDAR lens reads to the same base station. So we still do the GNSS RTK base station establishment on a control point, and we can have a team on the ground with rovers, and then we can have the bird in the air, and it all feeds to the same base. So it's all geo-referenced. And it really has we haven't had any limitations on satellite connectivity, because your bird is now 60 meters in the air, and it takes away that limiting canopy, the canopy limitations that you would have if you just running a rover. But it reads on the exact same base station. So our base file is just quite a bit bigger.
Yeah. How far away can your base station be from your bird distance-wise?
So we've gotten 2 miles is a stretch. And so it kind of depends on the 1 mile is what I think we're more comfortable with. There's some projects where we're working on large bodies of water, and that reflectivity, that it has less interference from the base station to where the drone is, and we can get it a little bit further. So I feel comfortable that our base station, we can set it up, 1 mile from where the extent of our drone is going to fly, and it'll still read. And if it doesn't, it tells us, and it comes back to where it can read. So then we just have to, possibly relocate the base station if it's a really large project extent.
Yeah. Is this green LiDAR, Jeanne?
No, unfortunately, that was a whole nother. That was like a triple the investment. So our
that was going to be my question. Yeah, like how much more expensive is green LiDAR over red?
Yeah, well, to give you a frame of reference, our LiDAR setup, and we did, there's some cheaper options, but we really wanted to have the better quality. So our whole LiDAR setup with our lens and our drone was around $100,000. To get to the green LiDAR, and this was a year and a half ago, 2 years ago, it would have been $350,000. So that was where we decided that we don't necessarily need to have the green LiDAR, but instead we have sonar. So we do have projects where we can't wade the streams, and we have a sonar that runs single beam sonar on a boat, and then we collect the sonar to go along with the data set. So then we stitch those together, and the sonar also collects straight to our base station. So we can pretty seamlessly stitch the LiDAR, the terrestrial LiDAR, It has a little bit of overlap typically with the sonar. And so they're all reading to the same georeference control points. And then we come back and we have a really pretty seamless data set. So we have this hydrographic surface model, which has been really valuable.
Wow, that's so
And I have
cool.
some examples kind of showing some sonar, because actually this project site that I'm here at today, when I'm meeting with the landowners this afternoon, we did that exact same thing. We had sonar collection in the boat, and then we had to build the terrain based with the LiDAR.
Okay. Yeah.
So
yeah. I think while you're pulling that up, I just want to make it clear for maybe some of the listeners out there who aren't familiar with LiDAR, but green LiDAR will penetrate water. And so you'll pick up terrain under the water surface, which, of course, as you might imagine, is really nice to have. Red LiDAR will reflect off of water, so you don't see below the water surface with the red LiDAR. So
yeah, and there are some limitations with green LiDAR still. It's a lot better than it used to be, but sometimes depending on what the turbidity or the amount of air entrainment in the water column, you can actually have a limitation with the amount you can collect there too. So it's not a foolproof solution to collecting bathymetry data, but it can be helpful in certain environments. So
yeah.
So typically what we do is have a person with a rod getting those toe shots in the stream, combined with the LiDAR and then the sonar. This was just another example of how we use LiDAR to identify the potential for the restoration projects. And this is a great tool to share with clients too. But this is an area on the South Fork Snake River where we're looking at restoring, some channels that appear to the eye when you're out on the landscape to be high and dry. This was a project where it was previously farm ag fields, and then it was acquired to BLM, managed by the state. So we were brought onto this project to look at the potential. Okay, where could we look at some lateral habitat? And this just gives the whole stakeholder team an idea of how dynamic the river is and where these old flow paths are that are completely cut off and have been leveled and farmed. And so it really helps to visualize the potential of your restoration projects. And then from that, then we can start building the hydraulic model. And so on this particular project, we did have a boat with sonar, and we ran bathymetry through here and stitched together a model so we could get that complete hydraulic model surface.
Yeah, that's so cool.
How do you, Jeanne, handle when you've got a river that you want bathymetric data, but it's too shallow to get a boat in there and get your sonar equipment in there?
Oh, that's when the guys get a little wet. Yeah. I say guys, but we got guys and girls. Yes, they love that too. We have
you just get in there with the old school rod survey.
Yep. Yeah. Give them waders or shoes that can get wet, and they go to work. And then just more of a standard bathymetric topo survey.
I have another follow-up, Jeanne, for you. You mentioned something I thought was really interesting, and that we've seen actually on a couple projects recently, and that's the idea of trying to build a design in a channel that's really, really dynamic. It's exhibiting a lot of geomorphic change, and how you survey it one spring, and then the next spring it looks totally different. For somebody that does a lot of heavy restoration design, where I'm assuming there's riprap and large woody debris, RIT wads, other things that are actually being placed in order to achieve certain velocity and depth criteria. How do you work around a channel that is changing that much? Is it just a matter of collecting your surface data in the spring and then getting all of the analysis and the construction done before the following fall, or how do you work within that setting?
That's a great question, and really part of what we do is get a good understanding of the geomorphic processes that are occurring in there in the first place. So we don't want to put in a hardened log jam just to have the river move 20 feet to the right. So we try to, again, look at the larger picture of the landscape, not just a site-specific project parcel. We're looking at what's happening in the watershed, where the deposition, erosion, where the constraints are, and try to address, I guess, more of process-based restoration, so that we're not putting in hardened static structures into a dynamic system.
Yeah.
And that definitely takes, we work with a geomorphologist. Our engineers have a geomorphological background so that we can understand and we can have those conversations about, maybe the client wants us, okay, log jam right here, but in a really dynamic system, maybe we can have those conversations to talk about, the limiting factors. You might get a bunch of deposition here in the future. So how can we design something that is also more dynamic and just restores the processes that limit the landscape, the riverscape in the first place. So there's a lot of science in what we do. So it's not so we have an understanding, of why we got there in the first place.
Sure. So there's probably certain areas of a channel, for instance, where you just would say, hey, there's so much change occurring in this portion of the reach that we're not going to implement hard solutions here, right? We might do it further upstream or further downstream. Oh.
Absolutely. And that's one of our projects, like I mentioned on the Teton River. They came to us because they want a straightened river and they want to have their fence on it, and they don't want all this movement. And once we start looking at it, when we're trying to identify appropriate restoration targets, you really have to understand the geology, the historical analysis, and it's kind of this just geomorphic investigation of the past 50, 60, 100 years if you have the data. And that was eye-opening for the client because this was a project right downstream of the Teton Dam. So in 1976, the dam failed. You had this huge flood, and it's a sandy river, and it straightened the river. And so they bought this ranch with a straight river in 1977, and they expect that they built their infrastructure out, and they expected that the river is straight. And so we start getting into this geomorphic investigation and trying to identify restoration targets, and you have to have that communication with the landowner and the clients that we can't keep it straight. It's gonna keep it bending, but now maybe we can look at where they could give up a little bit of their landscape and where we could help direct those something that would be more suitable. So and again, the HEC-RAS and the LiDAR and the REM is so valuable as a communication tool to help them understand that.
Very, very cool. And is this the image that you have in the background here? This is one of, I'm assuming, your kind of merged topographic and bathymetric terrain data sets.
Exactly. Yeah. So, this is actually publicly available LiDAR. So we stitched our sonar into the LiDAR. We didn't have to fly this LiDAR, but this is an example where we had the boat. You can see it's a little bit choppy, and we ran some data points through here. The point cloud data from the LiDAR is much better than the sonar, but it's more data than what you would get from just cross sections in a foot bathymetry cross-sectional survey. So we've got this is the project that I'm actually talking to the landowners here this afternoon. They have over-widened it. They excavated in the middle of the creek to create more of a pond right in this run-of-river pond. So that's the existing surface. And what we were trying to tell them, of course, their limiting factors are temperature and sediment. The creek comes in and all this sediment just drops out in their pond that they dug 30, 40 years ago, and which makes sense. So having that conversation about sediment transport and velocity in general was good, but it really helped to show them the visual and to show them some of the, if I turn on some of the velocity layers, they could see, let's see, we'll just run through this. And we've got, so this is the existing condition, and I had already previously shared this with them, but just the explanation of why, yes, this is such a big depositional zone. So they weren't aware of that. They just wanted the sediment to go away, and they want it to be nice, cool water. So having this visual representation, I think, is such a valuable tool to share with stakeholders. So what we're doing, what we had proposed to do for this project is there's also a downstream culvert. So we were going to take out the culvert and put in just a AOP structure box culvert, lower it a little bit so it's a free flowing stream. And then if I turn off the layers, I can show you what we now are using the terrain modification tools quite a bit in the newer versions of RAS, which has been fantastic. So these are some of the areas that we proposed narrowing. Actually, they identified areas after I explained to them what's going on, and with the artificially over widening of this area. So we didn't do any of this in Civil 3D. I mean, the terrain modification tools that are now in this in RAS Mapper are fantastic. It saves so many steps of having to go into Civil 3D, grade a surface, because we're still in the conversation point. We don't even know if we're going to have a project here. It's more just concept development, and having this terrain modification tools are fantastic. So yeah, that I was going to show you that, and then we'll be sharing with them the new velocity results just to show, we can get the velocities to come through here. The reason we kept this wide is because they do have a house over here and they do like fishing, and they like the ponds. They do want some wider areas for their float tubes and the fishing. But with this terrain modification, we can really show how we're improving the velocities quite a bit. And there's so much more we could do as far as plot the gradient changes between proposed and existing. But right now at the stage, I'm just using RAS Mapper as a visual to show them the difference between what they're currently experiencing, to talk to them about developing different alternatives. So this is one of the alternatives that we came up with, which, yeah, I think the RAS Mapper tool it's been fantastic. And if you don't have that good data set, then your model just is a little bit less reliable, and then it's hard to have those conversations with the landowners when you aren't quite as sure what it's going to look like in the end.
Yeah. And Jeanne, for those who haven't used terrain modifications, what would you say the amount of time that it took to make the modifications to the channel that you're showing here?
These modifications, EIT Ella, I just hired her a month ago. She's fantastic too, out of Oregon State University. I gave this to Ella, and she had it done in a day. I don't know exactly the hours, but I told her that I wanted this Friday morning, and by Friday afternoon she had the model running. So and she's very new on HEC-RAS, so we were pretty excited to see how quickly it could all happen.
That's awesome.
So one thing you can have Ella figure out for you, maybe you've already done this, but doing a difference map between existing and proposed. And you can create that right here in RAS Mapper as well. It's not one of the default maps, and it's not one of the preloaded maps, but you can actually have a script run to create that map for you. But
yeah, and that would be cool because it would show the differences in channel velocity throughout this area here. So
you'd see great in one map where your biggest changes are and by how much. But I was curious, Jeanne, you might have mentioned this before and I missed it, but the modifications you put in here, are these just fill material or wood or combination?
So this is a project, it's a spring creek system, so they don't have a lot of flow fluctuation. So it's relatively static. It would take a long time to recover on its own. And this is expanding wetlands. So we've done a few projects on Silver Creek, Loving Creek area where it's very groundwater influenced and it's very spring based. And so we would come in here and maybe with, festal wraps and modify this so it's, instead of surface area, it's now wetland, and expand the wetland, which is great also for funding agencies. They really like that because you're expanding the wetland through here. So this would be an actual wetland that they can come out on, and we've done that successfully on several projects around here. I can show you pictures, but that's the idea of it. It would be, kind of these banks around here are just wetlands until you get outside of the river floodplain.
Gotcha.
Super cool.
Yeah.
Jeanne, you also mentioned, I think yesterday when we were prepping for this podcast, that you had an interesting project in which you were kind of having to get a little bit creative with the calibration data that you were using. Do you want to talk a little bit more about that project?
For sure. Okay, so we did a project on the Lemhi River. It's actually multiple phases. We're still going into construction next year. So it's one of those projects that we had the opportunity of monitoring over several years because it's a multiple phase project. So we initially got a data set, and then we had designed a side channel. So we're building some constructed riffles. I'll pull up a picture here. There we go. So yeah, zoom in a little bit on this. So this is after the implementation. This shows what we did through phase 1. And the river used to be, this is the Lemhi River. It used to flow right along the toe of this bedrock bench and just cut straight through here. So, well, no, I apologize. It actually came through here and then it went over here. So the new meander is this section. You can see my mouse, correct?
Yeah.
Okay, so it cut through here and then came over here and through here. So we went and did some floodplain grading and the limiting factors here are lateral habitat for Chinook and salmon. I'm sorry, Chinook and steelhead, winter rearing and summer rearing. And so there's a big groundwater influence right here. And there were some kind of just ponds that I don't know. I'm trying to think what the original cause of those ponds were. I think the landowner had just excavated decades ago for some gravel. And so there were some ponds back here that were not connected to the channel, but yet Fish and Game had data that showed that these ponds were actually really cold water, very heavily spring influenced, groundwater influenced. So we wanted to introduce flow connection to the ponds here and introduce all of this lateral habitat, and then also just make the river a little bit more complex. So we have bank roughening, wood structures along here. There was an irrigation diversion component, and then we created a lot of side channels, lateral habitat through this peninsula. The phase 2 portion that hasn't been constructed yet is to put another riffle through here, so that this would get inundated even more, because again, we're limiting factor in the Lemhi is lateral habitat. So we're trying to have a lot of little hidey holes for the juvenile fish to grow, and kind of a nursery type condition for juvenile Chinook. So in this project, between phase 1 and phase 2, we had an opportunity to get to witness a flood event, which is pretty intimidating for a designer to have your project flood shortly after it's constructed.
Yeah.
Wow.
So this came back. It was just under a 10-year flood. I think based on the hydrology, we estimated it was about an 8-year, between the 5 and the 10-year event. And so the landowner was a little concerned, and then the Fish and Game had called me, and so we came out and we flew the drone again, which was great because we get this inundation layer. And since we're still designing for the second phase of the project, now we have this inundation layer that we could use to calibrate our model, which, you know, I haven't had this in my 23-year career of building these projects, that you have a flood condition in the middle of, you know, like in between different design stages. So the benefit of this was that we used this, we created a shapefile of this extent of floodwater the best we could, and then we used that to calibrate the model. And so here's the image that shows the inundation area. I'll have to zoom in on here a little bit. So that was so we exported the inundation area from our HEC-RAS model, and we put it over the flood event. And we did this just shows our 2-year model, but then we also did this for our 5-year model and our 10-year model. And it kind of fine-tuned it, which was a great opportunity. So then we did end up adjusting some of the Manning's roughness input in the model so that the model represented what was seen on site, and that was a fun exercise. I mean, it was really valuable, you know, because again, sometimes you're producing these models and you're producing these designs to the best of your professional knowledge, but the opportunity to actually fly it afterwards and then overlay that layer onto your model was pretty valuable.
Mm-hmm. How much channel change did you observe pre and post flood?
There was some side channels that, these areas that hadn't been, I mean, they've been connected, but the second phase is to put this riffle in right here, as I mentioned, and seeing the opportunity to actually have the flow patterns before the riffle was great. And there was a little bit of channel change in here, but our big meander, not much. There really wasn't channel change. It was more of just that the increase in the wetland vegetation and these overland flow extent. So we didn't previously, this doesn't have a lot of wetland plants in this peninsula right here. So we didn't previously identify it as very, I guess, connected to the floodplain. So in the second phase, we also looked at possibly inundating this a little bit more, but then that ran risk of downstream because you got a bridge right here. So that was tossed out. But yeah, there was a little bit of channel change. This section of the Lemhi River isn't that dynamic. So there's, depositional zones typical that we see at our side channels, but not too much.
Yeah, that makes it a really good calibration data set then, right? Because one of the downsides of using, flood aerial imagery is, well, if you had a bunch of channel change, then you're going to have to incorporate that channel change in your model. But if you don't have a lot, then it's an awesome, calibration data point that you can use. That's really, really neat.
Yeah, absolutely.
It's very cool. So, Jeanne, I've been wanting to ask you about this because you're doing this every single day. And this is an area of interest for me and has been for several years, but modeling wood in HEC-RAS. There's several different ways you can do it. I'm curious, when you're designing wood structures, whether they're engineered log jams or bank revetments or choking a river or stream with wood, how do you represent that in your models?
We typically do it through the roughness Manning's value, our Manning's in. So log jams, maybe change the Manning's in something all the way up to a 1. We've used a 1 before. And that seems like a pretty accurate way. I know, I've listened to a lot of your blogs and vodcasts before, so I know there's multiple ways of doing it, but that's the way I found is the quickest and easiest. But granted, now that I'm running the company and I don't actually get into the details and the technical analysis, so I've got very bright hydraulic engineers that know the ins and outs of the modeling, and they might have a different answer. But I do know that that's one of the more successful, more common ways, is just adjusting the Manning's in for those proposed conditions. And then also the terrain modifications too.
Right. Yeah, it works really well with the N value. And there's some other ways like modifications, or, some people have been experimenting with like pier piles, but there's no like perfect way. That's the challenge with modeling wood in streams. So yeah, I do like the N value approach because it gets you what you need, and it's simpler than trying to discretely model everything in the river. Have you tried out the new tree stamp in the modification shapes? Jeanne,
no,
have you seen that?
I didn't even know about that. I would love to.
Yeah, you could stamp a tree right into your terrain, but it's really just a T shape, so it's got the tree and the root wad in there, but you can just stamp them all over the place and orient them different directions and make them different sizes and whatever you want to do. Yeah, it's kind of cool.
Put you on the spot. Can you show us, or is that too much?
Hey, pull open RAS Mapper. I'll show you right now.
Okay.
Because you've got your project there, right?
Yeah, I do. And let's see. Okay. So just so you guys know, my Teams did freeze, so I can't stop sharing my screen, but feel free to share your screen on top of it. Okay. I'm working off the Starlink remote site, so that's okay. Okay, yeah, show me how to stamp a tree, and say we want to put like a log jam somewhere.
Yeah, so if you go down to any of your modifications, maybe the one you have turned on already, just right click on it and do add modification. shapes, and then at the very bottom there's large woody debris. And I wish they just named it tree, because that's all it is. It's not.
That's all it is, exactly. Yeah.
But if you just accept that, and then now you can just stamp your tree wherever you want.
Oh wow! So when did that come out?
That was pretty recent, like maybe a year ago or so. I think it came out in version 6.5.
The cool thing about this, if you click on it, Jeanne, then you have the ability to change the elevation of that tree, the diameter, the length, the orientation in terms of angle. You can change the shape to be triangular if you want. So it's pretty detailed. Again, not to the level that you would maybe necessarily need in like a final, stamped engineering design, but a great tool for kind of that feasibility assessment, which is what you were talking about. You really enjoy about the terrain modifications. So
absolutely.
Yeah. One of the downsides is it water can't flow under it. A lot of times you'll have trunks that are sort of kind of propped up onto a bank or held up by their root wad, and you get flow going under it, which is, I imagine you would agree with me, Jeanne, nice habitat, right? But this is just literally raises the terrain in the shape of a tree. Yeah. So if you zoom in, you can kind of see what it actually looks like there.
Oh, that's great.
Yeah, you have to turn off your results to kind of see what it looks like in the actual terrain itself. But that's true.
Okay. Oh, nice. So it is just stamping it into the tree. Okay. Oh, that's great.
Yeah, it's pretty cool.
Yeah.
This is me on my without my mouse. Sorry.
You just want to get really close to the tree.
Yeah, I needed to check it out nice and close.
Well, Ben and I, kind of on a side note, Ben and I recently flew to Atlanta, and we were sitting next to each other on the plane, trying to do like RAS modeling on just a laptop is really challenging. So I'm impressed, Jeanne, that you're managing here, because I need my 3 screens to really be effective when I'm doing RAS modeling.
I am borrowing their TV, so I'm in this cabin. I have an HD cable to the TV, but I forgot my mouse, so I'm just on the little laptop computer keyboard. But that's fine.
Cool. Yeah. Well, we'll have a few minutes left, but Jeanne, is there anything else or any other projects that you wanted to talk through today before we get to kind of closing out the conversation?
No, that was great, and I definitely appreciate learning the new tricks and tools, and that's why I think your podcast is valuable, and why I like to follow along, because there's a lot of versions that come out. I don't know the frequency necessarily, and maybe you guys can elaborate on how often are these new modifications and new additions coming out, and is there a good way to keep up on that so that we know features other than the website?
Yeah, I mean, other than the website, we try to make announcements whenever something, significant comes out. Yeah, so that was, I think, Jeanne, you just did a great plug for the podcast here, and the blog, and LinkedIn, we'll put stuff up there too, social media. But the other thing too, Jeanne, is get to know the folks at HEC. They probably won't like me saying this on a podcast, but if you can get to know them and get on their email list, you might get kind of first notice of when new versions come out too. So that's a good way.
That's great.
But yeah, I mean, certainly when a cool feature comes out, we like to talk about it in the next podcast we do. So it's a good way. Yeah.
And we're always trying to update our class material to reflect the newest tools that are available. So I know that when that stormwater feature and capability comes out, we'll have some revisions that we'll need to make to our course material, which will be fun.
Yeah, a lot of work but fun.
Yeah, exactly.
I imagine.
So
yeah.
Awesome. Well, thank you again so much, Jeanne, for coming on and sharing a little bit about not only the business that you started, but also how you guys are utilizing RAS within the restoration field. I think it's really, really cool to see not only, the results of these models, but how you're using some of the newest tools within RAS to kind of enhance the utility of the program. So thank you so much for sharing. Chris, do you have any other questions or kind of closing comments out before?
I just want to thank you, Jeanne, for coming on. It's been a real pleasure having you, but even getting to know you over, the last 5 years or so, and honestly, really appreciative of what you're doing, the work you're doing, and super proud of, the company you've built and the amazing award. Being named Idaho Small Business Person of the Year is no small thing. That is a huge deal, and we're super proud of you and excited for you, and congrats.
Thank you. I appreciate it. And Chris, I feel like I've known you through the whole journey since we first met, before I even started it. And then you came out for a pub and grub. We should do another pub and grub. And for those people who haven't been to a pub and grub, it's a really fun event, talking about multiple projects and examples and the latest and greatest. So you guys do some great events. So we appreciate that.
Yeah. We just had our 2024 pub and grub in Atlanta. It was very fun.
I heard about that. I was actually thinking about coming because my sister lives there, and I had it on my radar, but I couldn't travel.
Oh, that would have been cool.
You got a lot of cool stuff going on. Jeanne, if for those folks that are interested in learning more about RivHab or connecting with yourself, what's the best way to do that?
That would be, I am on LinkedIn. Our company's on LinkedIn. Here's our website, rivhab.net. Reach out to me. This has some contact information, a little chat robobot that pops up that goes straight to me. So I'd love to hear from folks, and keep up the good work.
Awesome. Well, thanks again. We appreciate your time, Jeanne, Chris. Thanks for joining the conversation as always. This was a fun one. Hope folks found it interesting. If you have follow-up questions about river restoration modeling within RAS or starting your own business, make sure to leave those questions in the comments of the YouTube page, and we'll try to either answer those ourselves or pass those along to Jeanne if they're more specific for her. But again, appreciate everybody tuning in today. This has been Full Momentum and HEC-RAS podcast. So until next time.